Well, hey everybody, Mr. Reeves back with you. And in this video, we're going to be looking at graphing linear inequalities. But now we're going to look at graphing linear inequalities that are in standard form. So in my previous video, we looked at graphing linear inequalities that were in slope-intercept form. And we saw that when you graph an equation, let me go ahead and just do a quick review here. Y equals 3x minus 2, say. You graph an equation, every solution is on the line, right? But if we went ahead and changed that equal sign to a less than sign, we could see that, okay, now we have all the values that are below the line. And of course, if we change that less than to a greater than, now we have all the values that are above the line. And notice when it's less than or greater than, it's a dashed line. If we go ahead and throw the equals on there, we get a solid line, right? So this one would be less than or equal to the line and everything below it, right? And greater than or equal to would be the line and everything above it. All right, so that is graphing a linear inequality in slope-intercept form. But guess what? Many inequalities are not in slope-intercept form, right? So for example, if I had 3x minus 4y equals 12. Again, I'm going to go back to the equation first. All right, that line shows me all of the values where when you take x and multiply it by 3 and then subtract 4 multiplied by y, you get an answer of 12. All right, and notice they have the x and the y-intercept marked off. Remember when we were graphing equations in standard form, we would often make what I fondly call a mini table. And we put in 0 for x, right? And we say, okay, in fact, let me go ahead and get out my handy dandy Moby here. All right, there's our work from our previous video. All right, so if I were to do this first one, 3 times 0 minus 4y is equal to 12. Of course, this part goes away because when you multiply by 0, you get 0. That's why we chose it. Then we have negative 4y equals 12. We divide by negative 4. We get y is equal to negative 3. All right, so 0, negative 3 right there. That is our y-intercept, okay? If instead of putting in 0 for x, we put in 0 for y, 3x minus 4 times 0 is equal to 12. Well, now that part goes away. We get 3x is equal to 12. We divide by 3. We get x is equal to 4. All right, so there are two solutions. And of course, we could go through and find infinitely many more values that make it true. It's just a lot harder to do to come up with these solutions when it is in standard form. All right, but what if I wanted to? All right, what if instead I wanted to go ahead and find less than? Let me go ahead and put that in. So when we put in 0 for x, we got negative 3, right? Whoops, negative 3, Mr. Reeves. It's really not that hard. Negative 3, Mr. Reeves. Let's try one more time. 0, I don't know why I'm having such a hard time this morning. 0 goes to negative 3, there we go, and 4 was there. So there's those 2 points. But what if instead of equal, I wanted it to be less than? All right. All right, so let me go ahead and add another table. Okay, and let me put in 0 for x. All right, and now what do I want? I want a value of y. Now, what we did before was we just looked right here and we said, well, I just want a value of y that's going to be smaller than negative 3. The problem now is we don't have an equation that says y equals. So where are all the values going to be if I want to do 3x minus 4y is less than 12? Because that's what I want to do now. 3x minus 4y is less than 12. Where are those values going to be? Are they going to be down here? Because remember when we did slope-intercept form, the less than values were always below. Are they going to be below the line? All right, or maybe it's switched around for standard form. Maybe they're going to be, maybe they're going to be above the line. Well, they have to be on one side or the other, right? I mean, we don't know what it's going to be, right? Okay, so there's a quick and easy way to find out. All right, and it goes along with our theme of standard form. Remember, if you've been listening to me, I said the reason we use zeros to find those points because 0 is the easiest number in math to work with, right? Well, guess what the easiest coordinate plane number or value or ordered pair, I should say, is to work with? It's right here, 0, 0, right? So that what we're going to do is we're going to check 0, 0. We're going to check 0, 0 and see, is it a solution or is it not a solution? And again, I want to remind you, we're looking at 3x minus 4y is less than 12. This was our equals. That's what we have. We want to know, is that a solution? Is 0, 0 a solution? Okay, so here we go. 3 times 0 minus 4 times 0 is less than 12. Well, 0 minus 0, and again, this is a question mark. Is it less than 12? Well, 0 is less than 12. Yes. All right, so what does that mean? That means 0, 0 is a solution. And where are all of the solutions when you graph a linear equality? They are on the same side. So that means in this case, even though it was a less than, the shading goes above the line. All of the solutions are going to be up here. Does that make sense? Okay, in fact, we can check it now. Let's go ahead and go to this inequality, and let's change it from an equals to a less than. All right, and you can see they actually all go above it. And again, just like with inequalities in standard form, if it is less than or greater than, you're going to get a dashed line. If instead I change that to less than or equal to, now I have a solid line. It's weird looking at a less than or equal to and having it go up, huh? Because you think less than or equal to has to go down. But that's because this inequality was in standard form, not in slope-intercept form. Of course, that means greater than or equal to. You know where that's going to go, right? Greater than or equal to then has to go down, all right? That would be all the values that when you put in x and y, you get a value greater than or equal to 12. Equal to 12 would be on the line. And of course, greater than, we just get that dashed value there. Okay, so what do you want to do? You want to graph the line, and then you want to check 0, 0. Okay, so just like in the previous video, let's go ahead and look at an example. If we were doing this on paper without any technology at all, what would we do here? All right, so again, let me sketch my coordinate plane. There is my y-axis. There is my x-axis. Let me go ahead and put some grid lines on here. 1, 2, 3, 4, 5, 6, 7, 8. I guess these are tick marks, not grid lines. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Mr. Reeves can count. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let me come up with a standard form equation. All right, so what about 2x minus 3y well, let's start off with the equation. 2x minus 3y is equal to, let's say negative 6, shall we? All right, 2x minus 3y. So in standard form, again, the easiest thing to do, in my opinion, is to put in 0 for x and 0 for y and find those x and y intercepts. All right, for every x-intercept, y is 0. For every y-intercept, x is 0. All right, so I'm going to do first 2 times 0 minus 3 times y equals negative 6. Those go away. So I get negative 3y equals negative 6. And when I divide by negative 3, I get y is equal to 2. All right, so my y-intercept is 2. Okay, now let's find my x-intercept by putting in 0 for y. So here we go. 2x minus 3 times 0 equals negative 6. All right, those cancel. I get 2x equals negative 6. I divide by 2. I get x is equal to negative 3. There is my my x-intercept. Okay, and then again, if this is an equation, then I would simply draw a line that goes through those points, and anywhere on that line, 2x minus 3y is equal to 6. All right, so in fact, let's do this. I'm going to write it. 2x minus 3y is equal to negative 6. All right, that is going to be my blue line equation. All right, but what about if I want to do 2x minus 3y is greater than or equal to negative 6? All right, so what am I going to do? I'm going to check 0, 0. So here's 0, 0, right? I want to know, is 0, 0 a solution? Let's find out if it is. Let's check 0, 0. All right, so 2 times 0 minus 3 times 0, is it greater than or equal to negative 6? Well, 0 minus 0 greater than or equal to negative 6. 0 is greater than negative 6. Yes, it is. All right. So now I can say, instead of is 0, 0 a solution, I can say 0, 0 is a solution. 0, 0 is a solution to this inequality. So what does that mean? That means for this inequality, all right, all of the solutions are going to be on the same side of the line, which in this case is below the line, as 0, 0 is. I'm going to go down from the line. This tells me that all of the solutions to make 2x minus 3y greater than or equal to negative 6 are going to go down. So I would then shade everywhere down here. Okay? Which of course means then if I have 2x minus 3y is less than negative 6. Oh, by the way, I forgot something very important. All right, I actually would, of course, need to graph, since it was greater than or equal to, those green points are also included on that line as well. Okay, now if I want to do 2x minus 3y is less than negative 6, I don't have to think too hard, because if all of the greater than values are below, then all of the less than values must simply be what? Above. All right, remember on the line, they are equal. That's the equation. The less than and the greater than will always be on one side of that line or the other. All right, in this case, the less than ones are going to be above it. All right, the less than ones are going to be above it. So now I'm going to shade the less than. And again, it's weird to say less than going above the line, but when things are in standard form, sometimes weird things can happen. All right, now in this case, because it's a less than, I would get a line, of course, that is dotted or dashed, however you want to say that. Okay? All right, so you see how that works? So when it's in standard form, go ahead and find that line by finding the x and the y intercepts, and then check 0, 0. If 0, 0 makes it true, then shade in the direction towards 0, 0. All right, both of the examples we did 0, 0 worked. If I had started off with this, let me just do this real quick, because if I tried 0, 0 here, 2 times 0 minus 3 times 0 is less than or equal to negative 6. 0 is less than negative 6. That is false, right? Then 0, 0 would not be a solution. Not a solution. And that would tell me that I don't want it in my solution area, so I would shade the other way. All right, so again, in the two examples we did, 0, 0 worked, so we shaded to include 0, 0. If you check 0, 0 and it doesn't work, then you shade to not include 0, 0. So if we had done the pink first and then the green, we'd get the same solution. We just would have been shading away from 0, 0 first, and then we would have been shading to include 0, 0 next. All right, and I would be remiss to tell you that you can actually also, if you want to, if you prefer, you could take any equation that is in standard form and you can solve it for y. This is why we did that lesson on solving for y. So if I wanted to, I could subtract 3x from both sides, 3x, Mr. Reeves, from both sides. All right, this lesson we just did, get negative 4y is greater than negative 3x plus 12. And then I could divide by negative 4. And remember, when you divide an inequality by a negative, you must reverse the inequality sign. So I get y is less than 3/4 x minus 3. So that changes it from, remember, this is standard form, to slope-intercept form. And you could see we have our y-intercept of negative 3 and our slope of 3/4. Okay, up 3 over 4. Up 1, 2, 3 over 1, 2, 3, 4. And then we would have our shading below, because for a slope-intercept form, all right, once you have it in slope-intercept form, less than always goes down. So that is an option if you want to. All right, you can always change standard form equations or inequalities into slope-intercept form, and then you don't have to worry about that checking 0, 0, because remember, when it is in slope-intercept form, less than will always go below the line, right? Less than always goes down, and greater than will always go up. So that is another option, all right, that some students go, I'm just going to do that. I just like doing that better. All right, but it's completely up to you. All right, so that is how you graph inequalities, linear inequalities in standard form. Until next time, have a great day.